We are going to measure the third scale. Our multimeter will still come here. We are going to measure the resistance. So we have some resistors here. These are resistors component. They have their values. We don't know. So we need to confirm their values. There are several ways you can use to determine the value of a resistor. But for us, we chose a multimeter for today. Okay? So we are going to know the value of each component here, each resistance here. We'll have to use this multimeter to measure that. You will come here to your multimeter, to the measuring scale. You will have to check omega. Omega is here. This is the SI unit of resistance. The opposition in the flow of current. Resistance. So this one here. So we have to determine the value of this resistance component. So if you have a circuit, you want to insert some opposition to the flow of current, like limiting current, whatever, you'll have to insert a resistor so that you limit current in your circuit. We are not going into that. So we are just going to determine the value of this. Number one, what you should do, this should not be powered. It should not be connected in any circuit. It should be a component like this one, a single component like this, turned off. Do not connect it to any circuit, then you expect to measure. You will get wrong readings. That is number one. It should be off and single like this. And if it's measured to the resistance of a circuit, that circuit must be off first before you measure. Then, number two, you take the select switch up to the ohmmeter scale. So, since I don't know the value of this resistor, they might be higher compared to 200 whatever. I want to set my multimeter at 200 kilo ohms. Because I don't know this reading. I can even put here at 2 mega, but let me just choose 200 kilo ohm. Then, I am going to connect this. Note that these are connected in parallel, meaning that you see these two terminals. So one terminal on one side, one terminal on the other side. This one does not matter. I can put red here, and I put negative here. I can turn this resistor, I can turn it again. So it doesn't matter. So let's connect. So I've changed the resistor. I've taken this one. So you can see I trimmed this because I used it in a circuit. So I can see I've connected the negative terminal on one side, the positive terminal on the other side, in parallel, across this resistor. Then I come to the multimeter. You see the red is at where omega is. Then, I said I've selected 200K. So you can see that this resistor is a 1 kilo ohm resistor. It's a 1000 ohm resistor. This is a 1000 ohm resistor. You can see it's 1 point. So if you want to see again, you can still let it back, bring it back here at 20. You can see 0 point. So this is a 1K resistor. You can see it's still 0.9, it's still 1K. But when you bring it here, so this resistor value is above this scale. So you can see you get wrong readings. You get nothing here. When you put here at the highest, you can see it's giving you 1 kilo ohm. It's 0.9. You see this point here? There's a 0.9. So this is a 1 kilo ohm resistor. That is the reason why I'm insisting that when you're measuring, always put the highest scale if you don't know, so that you protect the equipment. So that is how you can measure a resistance in the circuit. These are small resistors. These are small resistors. There is large resistance in mega ohms. There is an instrument known as a megameter for high resistance, which this one cannot measure. This one can only measure up to 2 mega ohm. Anything above that, this one cannot measure. It will give you wrong readings. So that is how you can test and measure the resistance of an element or a resistance of a circuit. The fourth is to test the diode. Test diode. So we are going to test this light emitting diode. Light emitting diode. These are light emitting. They are diodes, but they emit light. I'm not going to details. Let's see how you can test this diode, either they are is functioning or whether it's functioning or not. So let's see how you can test it. So in this case, you'll have to come here. To test diode and measure continuity, they have the same scale and same point of, or same point whereby you can. So for us to be able to measure the continuity of a circuit, you come here. You see this sign. There is this sound sign, and you see this diode sign here. So meaning that you can measure continuity from here. You can also test your diode from the same point, the same scale. It will provide you the two readings. It will measure for you continuity, and it will test for you a diode. Okay? So let's see how we are going to test a diode. To test a diode has two terminals. We have anode and cathode. In the case of an LED, this one here, we have the long pin and the short pin. The long pin is normally the anode. The short pin is normally the cathode. So the long pin is the positive and the short pin is the negative. We have this rectifier diode. They are all diodes, but in different function. This one emits light. This one is for rectification purposes. So we are going to test this diode. Okay. So we're going to connect this positive to positive terminal and this negative to negative terminal. Always it's also connected in parallel, whereby positive to positive, negative to negative. Being here, let's test continuity. Like as you have selected, let's short here for continuity. You hear that sound? That shows that you can measure continuity at that point. At that point, you can measure continuity. Continuity is normally allow us to check the circuit, the full, if the circuit is complete. So measure continuity. Then at the same point, we are going to test these diodes. Okay? Let's see how we can test these diodes. So I have connected, let's see, the anode on the positive terminal and the cathode on the negative terminal. So when testing an LED, a working LED must turn on, must show you that the LED is okay. If it's okay, you will see it will turn on, and if it's faulty, it will not turn on. So if it's faulty, even if you connect the multimeter, so you have disconnected here. So if I connect here that this LED does not turn on, the LED is faulty. But if it turns on, that means the LED is okay. Let's connect and see. So you can see that that LED has turned on. So this shows that this LED is okay, still functioning. So if I disconnect, it must turn off. So if the LED is faulty, you will see that this LED will not turn on. So guys, that is how you can measure, you can test a diode, and you can measure continuity from that. So if it's large current, like we have explained here, so that is the brief we can discuss in this part 2. So we are going to discuss into details how to measure, how is continuity so important in electrical and electronics engineering. Measuring continuity. Why is it so important in electrical and electronics engineering? So in a digital meter like this, in a multimeter like this, you can power, there is no place to measure power, but in a DC you can easily calculate power is equal to voltage times current in a DC. But in a AC is very complex, whereby cos pi like this. If it's 3 volt, 3 phase, you add VI dot cos. Very, very complex. So if it's single phase, is this one, that 3 phase is that one. No, so we are not going to details in this one. So for you to be able to measure power, the AC power, single phase is normally like this, and 3 phase is normally like this. This is because voltage and current are not in phase in AC current. So they are not in phase, they are out of phase. There is an angle of displacement between voltage and current. So that angle of displacement is given by cos pi. In a single phase, that's voltage current times this one. Then in a three phase, you add a root 3. So there is an instrument designed to measure this phase displacement. It's known as a wattmeter. So the power is normally watt, whereby, and I don't want to go into details into this. We have power. We have 3 types of power: apparent, active, and reactive. So this one is normally active power. Then we have apparent is in S, is in VA. Then we have VAR. This one is in VAR. Then this one is in watt. Voltage amps. This one is in watt. So something like this. So that is how power is complex in AC, in alternating current system. We are not going into details. So if you want me to discuss this one kindly, let me know on the comment section, guys. So let's meet next time on the measuring continuity in AC, in a electrical and electronics circuit. Thank you.